পরে খুশিকে নিয়ে যাবে হলো বাবু।
হ্যাঁ
বাবু আমি শুনতে পাচ্ছি না বাবু। থাকো
block of mass m is placed over a smooth inclined plane fixed inside a lift moving upward with constant speed v. Power developed by the normal reaction on block by inclined plane from the frame of the lift is. So we know that power is work done by time. Mass m is moved over a smooth inclined plane by fixing a lift moving constant speed v. Power developed by the frame of the lift is. A block of mass m is placed over a smooth inclined plane fixed inside a lift moving upwards with constant velocity v. Power developed. So we also know that F into B. So what is F? Since it's constant speed, force should be zero. Mass m is placed over a smooth inclined plane fixed inside a lift moving with the upward with a constant velocity v. Constant velocity v. So we know that force is mg sin theta is here and mg cos theta is down. We need to find angle with the rest. So mg is here, displacement is here. So work done, power developed, which is normally force into velocity, but since it's in opposite direction, I think it should be zero. Let's check. Yes, it's zero. Since the block does not move relative to the inclined plane in the lift's frame, its velocity is zero in this frame, and thus the power developed by the normal reaction is zero. Consider a car with mass m that is accelerating on a level smooth road due to a single force F. Consider a car of mass m that is accelerating on a level road due to a force F. The power delivered to the car remains constant and it is denoted by k. At a particular instant, the car has velocity v, velocity u. How far must the car travel in order for its velocity to double? Consider a car with mass m that is accelerating on a level smooth road due to a single force F. Power delivered to the car remains constant and it is denoted by K. At a particular instant, the car has a velocity V. How far must the car travel in order for its velocity to double? How do you solve this? Check hint. Relate constant power to force and velocity. Then use work energy theorem to set up an integral for the distance traveled as a function of changing kinetic energy. Okay, let's see. So first, we know that power delivered K is equal to F into V. Hmm. Then use the work energy theorem to set up an integral for the distance traveled as a function of changing kinetic energy. Let's begin. The distance the car must travel for its velocity to double under constant pressure K is given by S is equal to 7 mu cubed divided by 3K. How do you get to this? Let's see. F is equal to K is equal to F into U. Kushi? Here. K? Come, come. Again, jump. Okay. Let's begin with the relationship between force, power, and velocity. Since power K is constant, force can be represented as F is equal to K by U. From Newton's second law, F is equal to ma. Substitute A is equal to dV by dt and dV by dt can be also written as what? dV by ds into V, or du by ds into V, same thing. We substitute m into V into ds is equal to, so m into V into, oh, this is m into A, force is equal to K by V. mv du by ds is equal to K by U. M du by ds is equal to K by V square. ds is equal to mv square by K into du. Now we integrate both sides. The velocity increases from u to 2u and the distance goes from 0 to s. Velocity moves from 0 to 2u and the distance moves from, okay, so v square dv, which can be written as v cube by 3 raised to the power of from 2u to u. Oh my god, bruh. 2u to u. m by k 2u cube, and you'll get 7e cube by 3 into m by k, so 7 m cube. So let's try this question. Basically, they've told that there is a constant power. Power is constant and force is constant. So we can write that force is equal to force into velocity is equal to power delivered. Now we can write force, since force is constant, we can write force as power divided by velocity. Now force can be written as du by dt into mass, which is equal to k by v. Now du by dt, instead of writing it like this, we can write it as v into du by ds into m. This will again give us k divided by v. We can write du by ds into m should give us k divided by v square. Now we take this into dv into v square, and we can write k by m into ds. So we integrate left side from, they ask how far must the car travel in order for its velocity to double. So from u to 2u it should go, and s should go from 0 to s. Now we calculate this, so v square dv can be written as v cube by 3 from 2u to u, and k by m into ds can be written as k by m into s. That's it. So then we can write this as 8v cube divided by 3 minus v cube by 3 is equal to k by m into s. What are they asking? How fast must the car travel in order for its velocity to double? How far must the car travel? So they're asking for s. So 7v cube by 3 should by m by k. 7v cube m by k, or 7mu cube by 3k. Option 3. Let's see if it's correct. Yes, sir. Till now, out of 7 out of 45 questions, 7 correct, 0 wrong out of work, power, and energy. If we get 45 out of 45 in this, it's going to be the greatest achievement of the day. Let's go. Water falls from a height of 60 meter at the rate of 15 kg per second to operate a turbine. Water falls from a height of 60 meter at the rate of 15 kg per second to operate a turbine. The losses due to frictional force are 10% of the input energy. How much power is generated by the turbine? Losses due to friction are 10% of the input energy. So basically, we should do 90% of the power we get. We know that power is equal to work done by time, which can also be written by force into velocity, force into acceleration into velocity, or force can be written as change in momentum. Water falls from a height of 60 meter at the rate of 15 kg per second to operate a turbine. I said, ooh. If not himself, then he has none. Lyric shows I took the blow and laid it my way. Not in a shy way. Oh no, oh no, not this. I did it my way. What is a man? What has he got to seem to be? One who kneels, the record shows I took the blow and did it my way, not in a shy way. Oh no, oh no, not that. I did it my way. Another word, one who kneels. The record shows I took the blow. I ate it up and spit it out. I faced it all. I stepped on and did it my Oh shoot! Mm, Water falls from a height of 60 meters. Height is equal to 60 meters at a rate of 15 kg per second. dm by dt is equal to 15 kg per second. To operate a turbine, the losses due to friction are 10% of the input energy. So, according to Gemini, dm by dt is also equal to m by t, which is stupid. So 15 is equal to m by t. You know that mgh by t is equal to power. So m by t into gh is equal to power. 15 into 10 into 60. So what? 9,000, because 100, 600 into 15. 6 into 15 is what? 90. 6 into 15 is the 9,000. 9,000 is the power. Now we need to subtract 10% of this. So 90 by 100 into 9,000. Screw you, screw you. 90 into 90 is 8,100. 8,100 kilowatt. So option B. Yeah. Let's go, let's go, let's go. dm by dt into a 5 kg block is projected on the surface of a 20 kg plank with 10 meter per second speed. Plank is sufficiently long and initially at rest. Given that the floor below the plank is perfectly smooth, magnetic work done by friction on the block will be. A 5 kg block is projected on the surface of a 20 kg plank with 10 meter per second speed. Plank is sufficiently long and it is initially at rest. Given that the floor below the plank 5 kg block is projected on the surface of a 20 kg plank with 10 meter per second speed. 5 kg block is projected on the surface of a 10.